Yeah, so I'm Alexei. I'm AWS ambassador, community builder, and leader of AWS user group in Kiev. And today we'll be sharing our experience of building landing zones. We collected this experience during 3 years, I guess even more than 3 years. And a couple of words about us, about Automat-it, who we are. Automat-it founded 11 years ago in Israel. We provide DevOps services. We build cloud infrastructures in AWS. Currently, we are present in 8 locations, I guess. And we have about 160 employees. We are premier tier partner. This is top level partnership of AWS. And we are experts in DevOps services, security, migrations. We also conduct well-architected reviews, different educational activities like immersion days. We also have huge experience with Kubernetes, and we have more than 300 active AWS certificates in our company. And we already helped more than 500 startups and other companies to succeed in AWS. So our agenda for today, first of all, a bit of history. What were prerequisites of creating landing zone? What is the landing zone actually? What is account structure and different options of organizing AWS accounts and organizational units? Security configurations, particularly control tower controls, centralized logging and CM, centralized networking in the landing zone customizations, and in the end, conclusions and Q&A session. So you actually can write your questions in the chat during the session. I will answer in the end. So during this session, we should answer the following questions. What is the landing zone? Who may need it and what for? So let's start from history, how it was in the past. There was a standalone AWS account. A team of people just opened account, used IAM users to directly log in there, create some resources, virtual machines, Lambda functions, databases, storages. Then company grows, new teams appear. They also log into the same account, create their own resources. And here, the questions arise: how to distinguish workloads from different teams, how to efficiently manage permissions, how to deal with service limits, and other. And in 2017, AWS released a service called AWS Organization. So now our team can have own AWS account, deploy their resources, and all accounts are controlled by management account. And all of them are in the same organization. And this management account is responsible for consolidated billing. So on the one hand, we can separately check costs for every team. And on the other hand, we also get volume discounts. some services, for example, S3 gives us discounts. Like the more data we store, the cheaper it became. And this is consolidated from all organizations, and it becomes cheaper for us in the result. Here we can configure single sign-on and more efficiently manage permission to AWS account. We can apply organizational policies like service control policies, tag, backup policies, and we can aggregate funding from different security services in one place. And actually, AWS organization is a baseline for the landing zone. So what is the landing zone? And first of all, it's multi-account environment built based on well-architected framework, and it's scalable and secure. Who may need it? If your company answers yes to one of the following questions, it may be for you. You need administrative isolation between workloads. It means that different people, different teams get access only where they need, where it's required for their job. You need limited visibility and discoverability of workloads. So we need to isolate different workloads, different environments from each other. We need to isolate and minimize the scope of impact. So even if some of your accounts or parts of application is hacked, it will not go further. And you need strong isolation of recovery and auditing data. It's about storing backups and logs securely. And what kind of problems the landing zone can solve for you? For example, you need to apply different security policies for different workloads. You need isolation on account level. You need to limit access to highly private data. You have different teams with different responsibilities and resource needs, as well as different business units may have different purposes and processes. You can have more convenient billing, and you can efficiently manage limit allocation and prevent situation when one workload affecting others due to reaching service limits. So service AWS Control Tower helps us to build landing zones. And when we open the console, we just see one button. We click it, fill several fields like email addresses for new accounts, home region for our landing zone, KMS key for encrypting logs, and just click it and wait about 30 minutes, I guess. And what is going on during this time? Control Tower has an AWS organization as baseline. It configures single sign-on, some basic SSO by default. Then CloudFormation stack sets and service catalog is used for creation new accounts, and a couple of new organizational units appear, security and custom. And in the security organizational unit, we have a new account called Logger Hive. By default, we have a couple of S3 buckets here, and logs from service AWS CloudTrail and AWS config from all account sent here. And the second core account is audit. By default, it has AWS config aggregator and some SNS topics for security notifications. But later, this account will be a central part for our security services. And other custom organizational units will have their own baseline according to our needs. And how the account structure may look like. First of all, management account. Yeah, as I already mentioned, it's responsible for consolidated billing, SSO, controls, and account factory for creating new accounts. Logger Hive by default has bucket for CloudTrail and config logs. And later we will create other buckets here for other types of logs. Audit account by default has config aggregator, and later we can use it as administrator of Security Hub and other security services like GuardDuty, Inspector, Messi, etc. And use chatbot or SNS for security notification. So these three accounts are initial part and default part of every landing zone. Next thing is more custom, but anyway, infrastructure organizational unit. What can be here? First of all, we can have a dedicated account for centralized networking here. Account for shared services, for example, for monitoring tools or anything you need to share. Account for DevOps tools, and a separate account for storing backups if you have such requirement. Then workloads organizational units. Here we can create accounts for different environments like production, staging, dev, or even separate different applications. Sandbox organizational units usually contains sandbox accounts. So every employee can have separate account for testing purposes, whatever they need to try. And here we just can fix and limit spendings, have this account disconnected from our central network for security reason, and suspended organizational unit is fully blocked for everything. So we can apply service control policies that deny everything and use this account for example, to move accounts that we are going to close here, or temporarily block account, for example, if some of our sandbox exceeds budget, or some of our account is hacked and we should temporarily block it. And how it looks like in real console. So the root organizational unit is top, and then we have development, infrastructure, production, security, and other. So organizational unit, it's kind of folder for accounts, and we can apply policies on organizational unit. So when our landing zone setup is completed, we see a green message that tell us that we already have 2 new organizational units, 3 accounts. We have basic SSO, and some set of controls, preventive and detective, applied to our landing zone. And here is an example of dashboard of Control Tower. Here we already have 11 organizational units, 22 accounts, and more than 100 controls applied to our environment. And we already can see that some resources are not compliant. For example, a couple of instances have associated public IP address, and this is not very good for us. That's why we created a rule and detect such instances. And we also have summary by organizational units and accounts. If at least one of applied controls is failing, so account became non-compliant. Control Tower has more than 500 controls. You can find needed control according to your requirements. And there are 3 types of controls. First type is detective. It's built based on AWS config rules. There are more than 200 built-in rules in Control Tower, and they cover about 50 AWS services. And we can also enable Security Hub that adds more than 300 rules, and Security Hub also has about 100 integrations with AWS services and different third parties. So a couple of examples of integrations. It's GuardDuty AWS service. It's a threat detection system that uses machine learning to analyze different types of activities and alert about some suspicious things in your environment. Inspector is used to scan operational systems and containers for vulnerabilities, and later you can use Patch Manager to fix it. Messi is checking files in S3 buckets and trying to find sensitive data, for example, numbers of credit cards. And all these findings are aggregated in one central place in Security Hub. The second type of controls is proactive. It's built on CloudFormation hooks. There are more than 200 built-in rules. These controls make sense only if you are using CloudFormation for deploying your infrastructure. And you can proactively evaluate your CloudFormation templates before they are deployed. You can reduce the risk of human error and avoid violation penalties. And the third type is preventive control. It's built on service control policies. There are about 50 built-in rules. And they are needed to define the maximum available permissions for member accounts in your organization. A couple of examples: you can apply region restriction. So you can block some region in AWS. You can limit permissions of some users and roles. So even if a user is admin in some account, anyway, you can limit his permissions from the service control policies side. And you also can limit service permissions as well. And here is an example of detective control. So this control detects whether encryption is enabled for EBS volumes. And I intentionally created CBS volume that is not encrypted, and it's displayed in our Control Tower console. We can see that we can see the volume ID, region, account where it's created, and organizational unit. And account went to the non-compliant state. Proactive control. Here we are trying to deploy a simple S3 bucket and backup policy, but we want the backup policy force encryption in transit. So if we try to create bucket policy without such enforcement, it will just fail. And preventive control example. Here we are denying capability to make public unencrypted snapshot. So as you see, I'm trying to do it as administrator, but again, anyway, I have error. You are not authorized to perform this operation. So we protect from such activities. And here is 3 initial accounts that Control Tower creates for us. First one is management. We can see the home region of our landing zone, a baseline configuration created by CloudFormation stack set, and directory type for SSO. In the baseline CloudFormation stack, we can see that it created organizational cloud trail for us. And here's the console of SSO that can be configured from the management account. We can choose identity source because there are many companies which already have their own identity source, identity provider. So when you start using landing zone, you don't need to create anything from scratch. You just use whatever you already have. And there are different useful configurations. For example, you can enforce MFA. That is quite important nowadays. We also have attribute access controls, and there are many things that can be used as identity provider, such as Azure AD, Okta, Gem Cloud, OneLogin, Google Workspace, and many more. And here's how it looks like. This is SSO portal. So we can use SSO for accessing AWS accounts as well as some third-party applications. In this example, we see that we use this SSO for Grafana, ArgoCD, OpenSearch, OpenVPN, and this access configured via SAML. As the second account is Logger Hive. We can see again baseline configuration, which was deployed by CloudFormation stack set, and the central S3 bucket for initial logs. And this baseline stack actually deploys a couple of buckets and bucket policies. And how it looks like from the very beginning. We have our isolated Logger Hive account with the S3 bucket. And when we create any new account in our landing zone, it will by default send logs from AWS config and CloudTrail to this central bucket. But we actually can continue and send different type of logs from different services and application as well. And some companies stop here and it's enough, but other companies may add CM. CM, it's systems that can analyze your logs in near real time and provide some findings. And there are many good solutions on the market from the CM. But I will show you one example. It's a free solution developed by AWS. It's available on GitHub, and it's built completely on AWS services. OpenSearch cluster is the core here, and we also have a set of Lambda functions which will normalize and convert logs of different formats to the formats that acceptable by OpenSearch. And this solution also provides built-in dashboards. And here is a couple of examples how it looks like. This is dashboard for analyzing CloudTrail logs. We can see summary for different AWS accounts, different regions. We can see sources of events by country, by IP address. We can see a map. And this is kind of security monitoring. Again, it's analyzing CloudTrail logs. Here we can see failed login attempts, root login attempts, unauthorized API calls, attempts to change security groups, network access, and other different things. This is example for analyzing access logs from load balancer. We can see which protocols are used, which methods, IP addresses, number of requests from them, URLs, user agents, and other things. Again, geography of web requests by country, by IP address. And this is example of monitoring database in RDS. So we are monitoring logs. We can see accounts, regions, IP addresses, source IP addresses where we connect from, authentication failures, different types of findings, as well as slow queries. And this CM system usually deployed to audit account. So audit account, as I said, is a central place for security services. By default, it has its own baseline, a couple of roles for administrator and auditors, a mail address for notifications, and baseline stack contains AWS config aggregator and mentioned roles. And this account usually acts as delegated administrator for security services. Here's an example of Security Hub. So we put audit account, here is delegated administrator, and next we just continue managing everything from this point. And here is a summary, what we can see in Security Hub. We have several security standards. All findings from all accounts and regions can be aggregated in one place. And then we can see them by severity, resource type, account, whatever. And let's talk about infrastructure organizational unit. It's not an initial part, but it's often used by customers. First of all, we can have a dedicated account for backups. And we use this backup account for service AWS backup and management account for applying backup policies. When we apply a backup policy, a new backup plan appears in the member account. Nobody can change it, can remove it from the member account. So this one advantage. Backup plan contains a schedule when we need to create backups, resources which we need to backup, rotation policies, if we need to copy backups to another region and another account or not. And after that, we just start backing up virtual machines, database, storage, and AWS backup supports 16 AWS services. We can have a dedicated AWS account for different DevOps tools, for example, Jenkins or other server, as well as artifacts storages like ECR, Artifactory, or whatever. It is centralized, and we deploy our products to the member accounts. Shared services, for example, OpenSearch cluster for storing logs from different accounts. For example, Prometheus for storing metrics, or Grafana for visualizing. And our member accounts send logs and metrics to the shared service account. And here we also can provide access for our support team instead of granting access to the production. And networking account usually contains central transit gateway. This transit gateway is shared between other accounts. And when we create VPCs in member accounts, we can automatically attach it to the central transit gateway. We can also connect on-premises data center or remote office using IPsec VPN. We can deploy here IP management system, which will help us to allocate CIDR blocks and monitor their usage to avoid overlapping. We can have a central firewall, for example, AWS network firewall or any other third-party firewall appliance like Palo Alto or Checkpoint. We can have client VPN to provide remote engineers with capability to connect to private resources. And we can centrally manage DNS via Route 53. And this is one more solution from AWS called Network Orchestration for AWS Transit Gateway. It is used to automatically connect member VPCs to the central transit gateway and create appropriate routes. It contains two parts. First part is hub. It's deployed in the networking account. It contains transit gateway automation built on step functions and lambdas. DynamoDB as data storage, SNS for notifications, and here we also have optional part. It's web UI. For example, if you have a dedicated networking team that would like to monitor and approve or reject attempts to attach to transit gateway, so you can use it. And the second part of solution is spoke part. It's deployed to all other member accounts, and it contains event breach rule. That is checking when you add appropriate tags to VPCs and private subnet. So once you add appropriate tag, this event goes to the hub and automation is working, and your VPC is automatically attached to transit gateway and gets appropriate routes. And here is one more option of centralized network with a central egress VPC. So instead of creating NAT gateways in every member VPC, you can use the central one and just pass traffic through transit gateway to the egress VPC and then to the internet. It may be a bit more expensive than the default setup, but sometimes it's pretty useful for security reasons. And more advanced setup where we add firewall for traffic filtering. Again, our spoke VPCs have default route to the transit gateway. From the transit gateway, it goes to firewall. If firewall allows traffic, it goes to the central egress VPC and in the internet. And so we saw many different things that we can deploy to our landing zone, and there is a question how to automate it. There is a solution called AWS Control Tower customizations. It's available on GitHub, and idea is that we store our configuration in Git repository. This configuration contains CloudFormation templates, service control policies in JSON, and manifest file. And in this manifest file, we actually write where and what we want to deploy. We have a code pipeline with 5 steps. First step is we just getting our code. Then this code is validated. Syntax is checked. All needed input parameters. There is also some security scan. And by default, it will not allow you to create IAM role with wildcards. Then we can have a manual approval. It's optional thing, but sometimes it's pretty important, just not to deploy automatically to the production. The next step is applying service control policies. It's applied using step functions. And the last step is creating CloudFormation stack set and deploy needed resources to the accounts. And there are 2 possible triggers of these pipelines. The first one is updating code in Git, and the second one is creating new account in our landing zone. So, for example, if you deploy something to the production organizational unit and you create a new account in this organizational unit, it will automatically receive all resources that are mentioned in your manifest file. So what is CloudFormation is not for you? For example, you want to use Terraform. Here is the solution. It looks similar to the previous. Actually, idea is the same, but here you use Terraform modules. They are stored in Git repository, and using some automation, you deploy your Terraform modules to different accounts within your landing zone. And let's summarize. We have our landing zone built. What is next? Next is day-to-day work. For example, we want to create a new account in our landing zone. We send a request, a new account appears, and here we automatically get configuration of SSO. We automatically enable security services and monitor findings. Automatically sending logs to log archive. Connect our VPC to the central network. And sending backups to the remote storage. And how we as a company did it. We have a solution. It's available on Marketplace. It's solution service. And we just gather requirements. We speak with our customer to understand which part of landing zone their needs. Then, just as building blocks, we set up a landing zone, and it requires just a couple of days for us. And conclusions. So actually, what is landing zone? Landing zone is about centralized management, security best practice, isolation and access control, and visualization and notifications about security. Important thing, remember about costs. AWS organization and Control Tower, they are free. But we have AWS config. And if your organization is big and dynamic, you have a lot of events every day, AWS config and Security Hub may become quite expensive. So it's a good idea to set up budgets just from the very beginning. And what we can discuss next time, centralized networking in details with all automations, traffic filtering, firewalls, Control Tower customizations using CloudFormation and Terraform, Security Hub integrations, and CM. So thank you. Your questions? I'm opening the chat. So the first question, how to keep control of costs for Lambda in CM solution? This CM solution is quite cheap if you just want to test it. For example, it can it can cost about $50 per month. But of course, the price will increase according to your number of your events, volume of your logs. So how to keep control? You can monitor only logs you need. For example, you have separate S3 bucket for every type of logs, and you don't push everything to your CM solution. So this is one option. What kind of work, what workshop would you advise for practicing landing zones, creating and managing? I guess AWS has some workshop, but I don't know for sure. When we started building all these things, Control Tower was pretty new, and there was no any workshops. But I guess it's you can find it somewhere today. How can we estimate the use of landing zone with all the services? I don't know how to estimate because different companies can have different usage of AWS cloud. For example, some companies can have thousands of instances up and down during the day, and every instance also creates events for network interfaces, for volumes, and as a result, it's just hundreds of thousands events per day, and in this case, config may become pretty expensive. But we have solution even for this situation. We just can exclude some events from AWS config. There is a function, it's quite new. I guess it appeared last year, but you can exclude some kind of events and keep your costs under control. Can we use Terraform for Control Tower customizations instead of CloudFormation? Yes. There is a pipeline solution called AFT, Account Factory for Terraform, and you can use Terraform. Is it done with CDK? I don't know. Didn't see such solution. If you want to use CDK, there is a LZA. It's landing zone accelerator, maybe. Yeah. Yeah. Mind sending the CM tool link, please? Yeah, sure. You can just Google CM OpenSearch GitHub, and you will find it. Congratulations on the marketplace solution. Thank you. Oh, yeah, it's somebody already shared link for CM. Have you ever had issues that somehow affect AWS accounts during Control Tower updates? I don't remember such things. Usually a control tower update is quite safe operation. Even if it fails somewhere, you still have your workloads running on separate accounts. So actually, what AWS releases in new control tower versions? They add new controls. They may update some runtimes of lambdas, for example, from Python 3.6 to later. And even if something is failed, it's just about this security monitoring things. So your application is safe. Just need to be careful with custom service control policies. If you have such, just remember about them. Do you use only control tower to manage organization or combine with infrastructure as code? If infrastructure as code is used, could you give a couple of examples? What is managed outside of control tower? What's about permission to root AWS account? Who has access to it to provision infra over infrastructure as code? About control tower customization. Different customers have different requirements. Some of them just need a very basic landing zone. So we just create multi-account environment, control tower customizations, and add new buckets for different types of logs, and that's it. Other customers may have more resources in the baseline, for example, networking. So by default, we add a custom VPC to every new account. Traffic goes to the central network, and everything else customer deployed themselves, even maybe using different tools, for example, Terraform or CDK. And for some customers, we can have whole infrastructure deployed via this customization pipeline, including VPC, databases, EKS clusters, everything. So about permissions, root AWS account, if you mean management AWS account, yeah, just a few people have access there. And for example, even if a person needs to make changes in baseline configuration, he or she may have access to this Git repository, update code, but without access to other services in the management account. So actually, it's quite flexible, can be configured from the SSO. What was the monthly final price for such CM setup in the organization? Again, depends on volume of logs. It starts from $50 per month and can reach like the big numbers, because as much logs you have, as more powerful OpenSearch cluster you need, the more frequently your Lambda function works, and so on. What are the best practices to use Git and Terraform? Any suggestions how to organize branches I want to deploy sandbox account with experimental AWS services, and if meet expectation, propagate to another account. I can't tell anything common. Like every company just decides itself how they want to manage this branching and budget alerts. Yep, there is a service AWS budgets, and you can create a fixed budget for any resource or all resources in total, daily, monthly, weekly, whatever, and send notification whenever it exceeds. Could you please clarify about transit gateway automation? If you need customized policies, like who can talk with who? Yeah, it is possible. There are 4 default routing tables in this solution, but you can add more. And using these different routing tables, you can apply them to the different networks. And in this case, you will isolate workloads from each other. For example, you have production staging development environment, and you have some shared network with DevOps tools. So you can configure it that every environment has access to the DevOps network, but they cannot reach each other. I mean that production cannot reach dev and so on. Yeah, there are links to workshops. Yeah, question. We use Control Tower customization to deploy cross roles for whole organization or individual accounts. Previously, we also used it for STP deployment, but we wrote a new pipeline for Terraform code and are now using it. What my question is, the problem is the role I commented out the part of manifest that is responsible for deploying a particular role, and the pipeline completed successfully, but the roles were not removed. Maybe you used old solution. They actually added this functionality not so long ago, and when you comment some resource and manifest, it removes them. So make sure you are using the latest version of customization pipeline. If the control tower has not been created yet, and I have about 10 accounts under the root account, what will happen to the current accounts if I create a control tower? Nothing, everything will be good. There is a document how to enroll existing accounts to the control tower. So you just will need to create appropriate IAM roles to the existing accounts. If AWS config is enabled, you will need to disable it and enroll them. Just need to remember about service control policies. If you have anything and you enroll your old accounts to the organizational units with service control policies, they may block something. But by default, a control tower doesn't block anything, so you are safe. Yeah, so I answered all questions. Yeah, So thank you all for coming. I will send you a feedback form, and it's pretty short. Please fill it. And see you in our next webinars. Bye-bye.